Hello seniors, in this video lesson we will answer a problem about continuity. So given the function, determine the possible points of discontinuity, analyze the continuity of the function at each possible point of discontinuity, and if discontinuous, determine the type. If possible, redefine the function to make it continuous at the point of discontinuity. So first things first, identifying all possible points of discontinuity. So automatically, all the values that are in the condition are possible points of discontinuity. So we have 0 and 1, 0, 1. And you see in the given piecewise defined function, the third condition in particular, you have a value that will make it the denominator undefined, and that is equal to 5. So it's also a possible point of discontinuity. Now, what we will do is we will check for discontinuity at all those 3 points. So starting at the first point, which is x equals 0. So testing for continuity at x equals 0. So remember that the 3 conditions must be satisfied for the function to be continuous at that value. If any of the 3 is not satisfied, then the function is discontinuous. But we have to check for the second condition to determine the type. So let's check the first condition, what is f of 0. So f of 0 would be, we'll use the second condition because 0 is in the second condition, equal to 0. So substituting 0 to the second condition, the greatest integer function of 0 plus 3, that would be 3. So the first condition is satisfied, the f of 0 exists and it's equal to 3. Now, what is the limit of the function f of x as x approaches that value, as x approaches 0? Now remember that 0 is critical to the condition, so we have to check the left hand limit and the right hand limit. So checking the left hand limit, we will have the value, we'll use the first condition, so 3 minus 0 would be 3. The right hand limit, of course, the second condition, it's also 3. Therefore, the limit of f of x as x approaches 0 is 3. Now, the first condition is 3. The second condition, the limit is also 3. Therefore, the third condition is satisfied, meaning the limit of f of x as x approaches a is equal to f of a because they are both 3. Therefore, we can conclude that the function is continuous at x is equal to 3. Next, checking for continuity for the next possible point, which is x is equal to 1. So testing for continuity at x is equal to 1. What is f of 1? So f of 1 will be, we have to use the third condition because x greater than or equal to 1. Then we can substitute 1, no problem. So what's be 1 squared minus 4 times 1 minus 5 over 1 minus 5. 1 squared minus 4 is negative 3, minus 5 is negative 8. 1 minus 5 is negative 4. So negative 8 over negative 4 would be positive 2. Now, for the second condition, let's see the limit as x approaches 1. Now, left hand limit, we have to use the second condition, and since we are approaching 1 from the left side, the GIF of 1 approaching 1 from the left side would be 0 plus 3, the left hand limit. So let's just write that the left hand limit is equal to 3. Now the right hand limit is the third condition and it's equal to 2. So the left hand is not equal to the right hand, therefore the limit as x approaches 1 does not exist because the left hand is not equal to the right hand. In cases like this where the limit does not exist, mainly because the left hand is not equal to the right hand but both left hand and right hand limit exist, this type of discontinuity is called jump. So the function is jump discontinuous at x is equal to 1. The third, so testing for continuity at the value x is equal to 5. Now, what is f of 5? f of 5 is undefined because we cannot directly substitute 5 to the third condition. 5 is in the third condition because it's greater than 1, but we cannot substitute 5 to make the denominator 0. But checking for the limit, the function's x approaches 5 would be the limit of the third condition, which is x squared minus 4x minus 5 over x minus 5. Although we cannot directly substitute, we can do some manipulation in the given. So obvious manipulation here would be to simply factor the numerator, which will give you x minus 5 times x plus 1. The denominator is x minus 5. Now, these two will cancel out, so we can now directly substitute 5. So 5 plus 1 is 6. Now, the function is discontinuous at x is equal to 5 since the first condition is not satisfied. However, there is a limit as x approaches 5. So in type of discontinuity for this function, we say is point or removable. So the function is discontinuous at x is equal to 5, but the type of discontinuity can be removed, and therefore the function can be redefined. So how do we redefine the function? We simply add another condition to the piecewise defined function, that we will not include 5 for the third condition, and if x is equal to 5, we'll redefine the function to be equal to the limit that it approaches 6 to make the function continuous. Again, to summarize, you have to check the three conditions for continuity, and if a condition is failed to be satisfied, then the function is automatically discontinuous. And the second condition will tell you the type of discontinuity. If the function is discontinuous but the limit does not exist, mainly because the left hand and the right hand are not the same, the type is called jump discontinuity. And if the function does have a limit as x approaches that value but failed to satisfy all the conditions, but it has a limit, therefore the function's type of discontinuity is called removable and thus can be redefined, just like this. Now on to my favorite part. Best way to learn is do it yourself. This question is actually taken, this is a screen clip of a question way back in May 1999. So this is the question. I want you to answer this and check for continuity for the given piecewise defined function. If you have any questions, you know where to find me at room 508. And then if I'm not there, I'm the 10th floor. Good day.